Cool, so let's switch gears a little bit. There's something else I want to talk about. I want to talk about test versus single square bracket versus a double square bracket. We touched on this early in the course, but I promised I would go deeper in depth, and here we are. So let's talk about what I'm actually talking about here. We have a lot of files here. We're not going to jump into them yet, but what I'm talking about is the double square bracket notation, the single square bracket notation, and the test command, just so you know what's going on. Here's the quick little synopsis. Test is both built into Bash, and it also exists on your system. Single square bracket is exactly the same as test. The only difference is it requires a closing square bracket. That's just part of its syntax. But here's the thing. It's built into your system, and it's also on the file system. This exists. This is a program on your file system. I can run file bin open square bracket, and I can see it's an executable program. I can run it. I can do this, -f, etc password, close the square bracket, and then I can check to see that, yes, that file did exist. So it is a program that exists on your system, but it's also built into Bash. Bash does have its own thing, though, which is this. And as you can see, here's the difference. Test is a shell built in. Single bracket is a shell built in. This is a keyword. Keywords are slightly different. They have different rules about how variables are expanded, so you can get away with some stuff using double square bracket that you can't with single square brackets. When you're using single square brackets, you want to quote all your expansions because it's being executed like it's a program. The double square bracket, you don't need to quote your expansions. You don't have to quote every single expansion. Some you will want to, but you don't have to because it's a keyword. It's processed with different rules than built-ins are processed with. So let's go ahead and jump into some of this. Let's look at the first example here. Simple test. If test-f foo.jpg echo foo.jpg exists. This seems pretty simple, right? We're going to run this command. It's going to check to see if foo.jpg exists and is a regular file. And if that command is successful, then we will echo that. So let's go ahead and run that, and it doesn't exist. So let's go ahead and create, what was it, foo.jpg, run it again, and hey, foo.jpg exists. That makes sense. That was very simple. Let's go ahead and look at this example. So this is the same thing, but instead of running the test command, we're just using a single square bracket, both the beginning and the end of it there. So if we run this, we should get the exact same thing, foo.jpg exists. Cool. Let's look at the next one. Simple double square bracket. The exact same thing, but we're using double square brackets. So let's go ahead and do this, and hey, we get the same thing. Cool. So they all operate pretty much the same way. Anything you can do with the single square bracket or the test command, you can do with the double square bracket, plus it can do more. I personally always use the double square brackets with Bash. I will never use the single square bracket or the test command. There's just no reason for it. The double square bracket does everything I need, and it's a keyword, so it's parsed in a different way than other built-ins are. So let's look at the next file here. We have O3 patterns. Now this is interesting. We make a variable called f, and we call it test.jpg. So we're not actually looking at the system for this. We just have a string called test.jpg, and we're checking if $f = star.jpg. So that's a wildcard match. What do you think is going to happen? Are we going to print that it is a JPEG file or that it's not a JPEG file? Let's go ahead and run it, and it is a JPEG file. Hey, that's cool. It passed the test. That is awesome. Now we have one called pattern fail. Man, I really didn't bury the lead at all with these file names. Same exact thing, but we are using single square brackets. $f = star.jpg. So let's go ahead and print that and then run it. And we can see test.jpg is not a JPEG file. This command expects a literal match. It's looking for an actual star.jpg here, so you better be careful with this. Also, if this file exists on your file system, you might want to be careful about this. If we touch test.jpg and then we run it again, now we get too many arguments because it expanded. Multiple JPEG files were in there. We can see we have foo.jpg and we have test.jpg. It expanded those in place and added it as another argument. So you got to be careful when you're using the single square brackets. This is why I stay away from them. Proper way to handle it would be like this. And then you can see once I quote it, I don't actually have the wildcard match. So this just isn't what I want. This is why I stay away from them. Let's go on to this one. With the double square brackets, we can quote it, and if we quote it, we will disable the expansion. So let's go ahead and look at the example 5, and then we'll run this, and we can see test.jpg is not literally star.jpg. It is not literally equal to that star. So if you want to forego the wildcard matching and you just want literal checking, quote the right-hand side of the expansion when you're in double square brackets. Quoting will disable any sort of special meaning, usually in the shell. The next thing we have here is numbers. So we have a = 9 and b = 10. Now we are going to use the double square bracket notation to check if B is greater than A. So B is 10 and A is 9. So is B greater than A? Well, yeah, 10 is greater than 9, right? So let's go ahead and look at this. We have B is greater than A, otherwise it's going to print, uh-oh. So let's go ahead and run this, and we can see, uh-oh. Well, this is weird. Hold on. Didn't I tell you guys to use the double square brackets, and now this is happening? What's happening here? Well, here's the thing. This notation, this greater than, is checking a string comparison between these two, and 9 sorts before 1, or sorry, 9 sorts after 1. It's comparing the 9 against the 1 here, so it's comparing them like they're strings. It's like an alphabet, or is it lexicographical sort? I might have butchered that term, but yeah, that's what's going on here. You would have to use a different notation instead of saying, what was it, 10 is greater than 9, which will be a failure. You would have to use dash GT for greater than, if I could find the dash character. Dash GT for greater than. You have to do that way if you want to compare them like numbers, okay? If you've done POSIX scripting, you've seen this before. Here's the thing, we're in bash. We do not have to worry about that. Circumvent all of that. So I already have a fix for it here. So I forgot I wrote this one, but yeah, I have a fix for it here where I fix it by doing the dash GT notation. Then you can see 10 is greater than 9. That makes sense. Here's the thing, we are in bash, okay? We're in bash, so let's not forget that we have double open paren. Just do the double open paren, B greater than A. We don't need to quote the expansions. Look at that. We run this and it compares them like numbers and it works exactly how we would expect it to work. So there you go. This is a quick little synopsis of test versus single bracket versus square bracket. I do have a longer form video where I dive into it more specifically, I think, and kind of just talk about some of the history of it and stuff. I can like every video, I'll link it at the end. I gotta stop shouting these out.